My English is not that great, so sorry about that. But, just to correct, my name is Juan Emoji Corn Lulkin. That's my new name. And I'm going to talk to you about asynchronous JavaScript. First thing, before I even start with the other titles, just to sort of decide which path to take for my presentation, how many of you are JavaScript developers? So most of you. And how many of you actually use promises on a daily basis? Okay, so I will skip a little bit of the intro. I'll give you some directions if you're not into JavaScript yet on where to get the basics, and I'll deep dive in the issues. So one alternative title for this, talking about philosophers, is you must keep your promises, except when you can't. And another one is the problem with promises. She's found her love, but lost her way. So this was like the first hit when I searched for promises problems, because I was trying to, compile problems to talk about, but then I found this book. It's apparently about this couple, and he keeps making promises to be nice, and she explains that the problem is not it doesn't matter, read the book, right? And obviously this would be also a nice title nowadays. I guess that's the main joke of 2000 and last years. So, very well. So, as I said, I'm not going to deal so much with the basics of asynchronous stuff. For those of you who don't know much about that, what I recommend is take a look at this video. So, all the links that I'm showing you here, you'll find in this repo. So you can go to GitHub right now if you have your computer, or later. All the code that I'm going to present, all the links are there. So you can dig deeper. If I go too fast in some example, you can always go back. So as I was saying, this is a nice video. This guy explains what the heck is the event loop. Wow, thanks. I didn't even finish, you see. And then he created this nice tool that explains visually how asynchronicity in JavaScript works. So they explain how save and run. So things that happen in the call stack goes to the web APIs, and everything that is delayed gets into a callback queue, and then eventually is executed after your code finishes the call stack execution. I'm going to skip that, and I'm going to go right away to promises and some general use cases. And I decided to talk about this thing for a couple of reasons. One of them is that this is like the ABC of JavaScript nowadays. Everyone who works with JavaScript has to deal with asynchronous stuff, promises, async await, whatever. And I noticed that there's always some knowledge gap. Everyone knows a bit, but there are some bits that are not very clear. So I decided to make a talk trying to show some problems and show some solutions so that we're all leveled. But first problem I encountered when I wanted to create this presentation is that I tried to ask people, what is the problem of promises in your point of view? And every developer had different problems. And when I started compiling these problems, I mounted up to 30-something. It's no, I can't talk about 30-something problems in 30 minutes. Too many slides, too much code to show. So I decided to focus on the things that bugged me. And I've been working a lot with this kind of stuff recently, especially in the Klarna app. We have, for instance, in the shopping app, we have promises going back and forth, the app and the web view. We have a tracking service where we model all these events as streams that we need to deal with asynchronous stuff. We have scripts that we need to run to deal with our mono repo that needs to run things in parallel, run things in sequence, make sure that things are stopped when other things break. So I've been around promises a lot in the last months, so I wanted to share a little bit of my recent experience. So let's begin by coding. This is the bad thing of doing live coding because I can't just walk around, but fine. So first thing we can do is to, let's say we want to, let's start with some sequential example, right? I'm going to sequential, then parallel, then problems. So sequentially means I want to do something asynchronous, and only when this completes, I want to do something else. So these are dependent tasks that I want to execute. So let's say I want to read some file, so I'm going to import the fs, and I'm going to create a function called read file. And read file gets two options. One is the path to the file I want to read, and some options. Fine. Since I want to use a promise, I will say that this guy returns a new promise. A promise has a resolve and a reject callback, and I'm going to do rs dot, rs, no, not this, rs again. This one is good. Yeah, not really. Never mind. Fs read file. And then I'm going to read file with my path, with my options. And as you know, there is a callback. This callback gives me either error or the content of the file. And what I'm going to do is that if there's any error, then what I'm going to do is to reject this with the error. If it works, I'm going to resolve with the data. So how do I use that? Right? This is an asynchronous call that will read the file, return me the result. So I can do read file. Let's say I want to read this file called A that I have in my project, and then I want to output, right, this to the console. So console log. So when I run this, I get a buffer. Nice. I need to pass another option to tell this guy to give me the file in UTF-8. Very well, I get B. So as you can see, this file actually returns me the name of another file. So imagine that these are like AJAX calls that you're getting something from a server, you get a response, based on the data you need to do another call to a server, and maybe based on the data you need to do another call from a server. So many asynchronous calls in sequence. So what I can do here is that I can do then again, and basically get the data from this first execution and read another file, right? So this file will be data, so file B, and I also want this to be a nice string. So when I execute this, I get C. So apparently there's like more things to do. There's a longer chain. So let's try one more time. Good, now I get D. What the hell? And then I get finally. So this is reading A. Based on A is reading B, C, D, and then D probably has this content finally. So as you can see, this is how we do sequential stuff using promises. There are some things we could improve in this example. For instance, we don't really need to write this whole read file thing. Two things you could do. One is to use the utils in node 8. As you probably know, you can import this promisify and just wrap these functions. As long as they return a node back or a node callback, they will work. But I generally prefer to do some other way, which is require this library. So this library is really nice because it gives me precisely what I want and some things extra. So fs extra wraps all the fs functions into promises and also gives you other things like rimref and mkdir with recursive and so on and so on. So basically this will work the same as the previous example, already wrapped read file in a promise. Final thing we could do to do this is to try to generalize any sequential computation into some sort of helper. So of course I already prepared my helper here. So sequentially, basically what I'm doing is that instead of trying to do then, what I want to do is like just pass a list of functions and execute them sequentially. So I have this reduce that will actually do like a then from the first promise to the second and so on and so on. So the way I use this helper is basically I can do sequentially, then I need a list, right? So this list will be first thing, read file, then, second thing, read file, so on and so on. I guess I need 3 times. Good. And this will also return a promise. So I can also, by the end of my sequential computation, I can do then and see the result. Let's see if it works. It works. Fine. We generalized any sequential asynchronous computation. Now the second thing, the second use case for asynchronous promises is probably parallel, right? I need to run things at the same time. You probably know that JavaScript doesn't really have parallel. Maybe you heard about that. So I'm going to talk about this a little bit. First, let's see what I mean by parallel in JavaScript per se. So let's comment this out. Let's start a different example. Let's use the most common example for asynchronous stuff. So let's create a function called wait or sleep or something like that. Number of seconds, and this will return a promise with a set timeout. So the set timeout will resolve maybe with the number, fine. Then number multiply by 1,000. So as you can see, I want to run this in parallel. Anyone knows how do I run, let's say I want to run wait 1 dot then console log and wait 2 console log. How do I run this in parallel? Any suggestion? Promise all, very nice. That's exactly what I was expecting. So let's say I have this list of promises and I want to run them in parallel. So let's create a list and then I can do promise all and my list. Very well.
Isn't this already parallel?
Oh, so this is already parallel, but I'll get there later. So when I run this with promise all, as you can see, it gives me 1, after 1 second 2, and then it completes. The cool thing about promise all, of course, is that that it returns another promise. So instead of doing console log on each of the things, I can actually just do then in the result of the all. So what I get in this case is a list of all the results by the end of it. So this is how we do parallel stuff in JavaScript using promises. But some of you, as I said, probably thought about, okay, this is not really parallel, right? This is still putting things in the callback queue and executing once you reach there. So behind the scenes is sequential, but it works for most of our use cases. We don't need proper multi-core parallelism for this kind of things. If you want multi-core parallelism, though, what you would probably look into is into child process. So child process has a function called fork, where you can actually execute JavaScript in different cores, or maybe cluster if you need something more complex. There are other solutions for managing processes in JavaScript as well, but these solutions, they don't work for the web, right? So in the web, luckily, now we're now getting close to Flash. So we now have web workers. And obviously, there's a library that abstracts all this away. So you can just use Parallel.js. Let me show you one example of this. So let's say I want to, let's require first Parallel.js. First thing I have to do is to create, let's say I want to read all these A, B, C, and D files, right? So I create a list of files with A and B and C. That's enough. And I need to wrap this with a new parallel. Very well. So now I need to explain what parallel needs to do. So what I can do is, like, let's say call this read, and read will be a function that gets one file and reads the file. But notice that in Parallel.js, I can't, for instance, do imports outside this function. This function is actually stringified. So it needs to contain everything to execute inside of it. So I need to do require fs here, right? And then, since all of these things are going to be run in parallel on its own, it's okay that I run this synchronously, right? Inside of the execution. So I can do read file sync with the file name. I want UTF-8, of course, and I need to return that, right? So now how do I use it? I just do files.map, and I pass the function that I want to execute. So this will execute read function, passing each of the files in as many parallel cores that you may have. And of course, this returns a promise, so I can do then console log. So this will give me the content of A, B, and C, which is B, C, and D. And it ran in parallel, and it works for the web as well. So enough for these examples. Now, let's look at the problems, right? So first problem is what Omri already noticed, right? If I go back to my previous example of the wait, we had this promise all, let's go back to this. So as I said, this runs in parallel. As you remember, this returns 1 and 2. But what happens if I just throw this away? So as you can see, it's still thinking, and it completes in 2 seconds, because it still executes my promises. So the first problem that I think it's quite problematic in promises is that promises execute immediately. And if you're not aware of that, this may have serious consequences. The simplest solution, if you want to make sure that you're running at the right point in time, is that you wrap it into a function, then you map and call this function, or do some workaround like that. But that's problematic for many reasons. And I would say one of the main reasons is my number 2 problem, which is promises don't have cancellation. So let me, for instance, show you this. Let's say there's another function in promises called promise raise. So the idea of race is that I pass a list of promises that I want to execute in parallel, and at least when I looked at it, I said, well, it probably returns the first one to succeed. That's my expectation. So I run this, and then I do then console log just to see which one succeeds first. Very well. So the result of this is 1. Very well. But you notice something strange?
You executed and returned, but it was
It takes 2 seconds, right?
ignored. Yeah.
Yeah, that's because 2 things. One is that these promises, they already started executing. So there's nothing we can do about. If I had like a wait 5 here, or imagine that something like may take a long time, you'll still be waiting for these things with no real good reason, right? Because I just care about the first one to finish. And there's no real way to cancel promises in the basic spec. There are some attempts, like some proposals, they were dropped, and I'll go over some solutions later. So race is not only broken in this way, but race is also complicated because actually if I change this to reject, or if I do something like math, random, let's just use the helper, yep, math random, let's say 50% to work, 50% to fail. It's good, so we reject, and we reject with some error. Cool. So now what this means is that it will try 1, it may fail, may succeed. So what happens with race now? So in the first example, fine, it works, it returns 1. It takes 5 seconds, let's remove this, it takes too much time. And let's try again. And now I have an unpromised, why is that? Right? It's because actually race returns the first one to complete, regardless of resolve or reject, it doesn't matter. So it's a little bit counterintuitive. So because of that, I added this nice article where this guy goes over all the issues with the race thing, like this, and so on. The fourth problem is that there are lots of common mistakes that people do when using promises, and this is when I got like such a huge list that I decided not to go over, but I'll show you one of the problems. So imagine that you want to create some function, let's say, let's require this, and let's say I want just one function that reads file A and returns in a callback style, right? Because sometimes you don't want to have a promise that deals with errors. You want to just use the promise and have an API for the user where he gets a callback and he deals with errors himself. So let's say read A, gets a file, and returns read file with, we don't even need the file, right? We can just, we actually want a callback, right? So let's call it CB. So we read the file A, and we do then. So if it works, we'll get a data, right? So we can do a CB node style, null, then data. And if it fails, we can do just error, and then we call back with the error. Very well. So now we do read A, and we have a callback, let's say console log. It's like a callback that I always use for everything. Oh, of course, I always forget the UTF-8, so we can see the result. So as you can see, it works, it returns no error, it works fine. But now my question is, what if I change this console log to some function that does skrzbdl? Any idea? Works, doesn't work, explodes, no idea? So let's follow the code then. So the callback is something that will throw an error, we know that. But we're calling this callback in the then, so it will fail, right? Because the callback will explode. And then it will go to the catch, but it will explode again, because the callback has a problem. And that's it. You have now another unhandled promise rejection. So I showed this to some people, and people, no one does that. That's not, people know about this. How common is this problem? Well, this common. So this is one of the top guys saying, hey, here how you should model your fetch stuff. So there you go. So fourth problem is that there are a lot of common mistakes. And finally, another thing that is confusing in promises is that you have actually a second argument to the then, right? So for instance, I don't have like a clear example, but you could have something like this, right? A second function that is supposed to treat errors just like catch at that point in time. But what is misleading is that you expect this function to deal with the error in the first function, and it actually doesn't. It deals with the error of the previous then. So if you really want to use it as sort of a recovery, it doesn't really work. The only way to recover things is to actually catch and then do then again and continue going. And the sixth and final problem that I want to present you is that everything in promises are thens, right? You don't have a way to distinguish, for instance, when you want to just map over a value or map over a new promise, or sometimes you want to just console log and continue execution, so you need to console log and then return the value again. So you don't have like this granularity of API in promises. Everything you do is with then. And then I get two more issues. They're not like specific to promises, but are specific to the way people use promises or the way people understand promises. One is that every problem is a catch. It's very unfortunate that Adam didn't manage to give his talk because he will be talking about other ways to deal with errors instead of just throwing everything that happens. And finally, not really a problem, but how can you, that's my question, like let's say you have this, okay, this example is nice. So imagine that you want something that instead of doing set timeout here does set interval. Can you use promises for that? Yes, no? Yeah?
You should return a new promise.
It will work, but it will return one value, right? To return the first interval. What you want here is like something that is like a promise, but returns you many values over time. So that's a different thing. So these are the problems that I see, and now let's try to take a look at some solutions. So first library that I tried to use when I encountered these problems, and I had, sorry?
Could you like return a stream of promises or something like that?
Return?
Like a stream of promises.
Yeah, but we'll get there, just a second. So I looked at the Bluebird, and Bluebird sort of fixes most of these problems that I mentioned, except it works pretty much like promises, so it has some of the gotchas. But it does have a canceling mechanism and some things like that, but it's still a little bit manual. So then I tried to look into something else, so I ended up looking at Folktail. So Folktail is a library that has a lot of types, and it has also a type called task that is supposed to replace promises. So let's take a look at tasks. So let's say we do the same example as before. We want to run some wait. So I have require Folktail, very nice, here. So we do const wait, receive some seconds, same as before. And instead of doing promises, I'm just going to return a task. So the difference in the API is that I receive an object called, I can call it resolver, right? And then what I can do is to do some set timeout, and the set timeout will do resolver.resolve with the seconds. And this will take secs multiplied by 1,000. So there you go. Now let's see if it solves the first problem. So the first problem is that it executes immediately. So let's run this code, and it finishes immediately. Because in this library, it doesn't execute automatically. You need to do something to execute this task. So the way you do it is that you can do, first we could do a map, so we can log the result, and then we call explicitly run. So run is actually what makes it execute. So it takes 2 seconds, it console logs, and it runs. And as you can see, it also has like different methods for dealing with regular values or other tasks. So you do map for regular values, you do change for tasks, and so on. Let's see if it solves more problems. So let's see if we can use a function called waitAny, which is the sort of a replacement for race. And I want to run, let's say, waitAny with a list of waits, so wait 2, wait 1. And I need to add one thing though. So I need to add the following. This thing returns me a timer, right? So I can use resolver dot what? Yep. It's where is it? Yep. Yeah, let's look at the documentation, much easier. Let's do it together. Oh, I don't have a translation. But it's clean up anyway. So, so this is the thing. when you do a cleanup, it sort of defines how you stop the execution of this promise. So all I have to do in this case is to do clear timeout. And I need to pass my timer. Should clean it. So let's run this. Let's see what happens. I get 1, and it finishes in about 1 second. What does it mean? It means that once it gets the first one that succeeds, it knows automatically that it needs to cancel all the other promises. So you can do code, to revert file reads or to revert whatever process you're working in a cleanup. And if you try with all and one fails, it will stop the other ones. Or if you try with any and the first one succeeds, it stops the other ones. So it solves, as you can see, a bunch of these problems that I showed to you. But finally, last but not the least, I wanted to show you this picture. You can see this in Eric Meyer presentations, and he calls it the general theory of reactivity. So the idea here is that when you have a synchronous value, you have this T, right? So a string or a number or something like that. And when you have a list, we call these things iterables, right? So an array, for instance. But when you have asynchronous stuff and you have one value, you call it a promise. But if you have many values, you call it observable. So an observable is what would solve the problem for having the set interval instead of set timeout. There is, of course, some talks about having an observable reading JavaScript, but of course there are many libraries nowadays that do that, like Rx or, for instance, Most, which we are using in the Klarna app. And what I want you to understand is one thing, that think about, okay, so imagine that I have a map over a list with only one item. Basically what I'm doing is applying the function to that value, right? So the same thing holds for the row below. If I have an observable with one value, what I actually have in effect is a promise. It's the same correlation. So every library that gives you observables already gives you promises. And if they have tools to solve cancellation and things like that, they will be a good thing to use. So just for an example, let's try most a little bit. So most, we can use periodic. So periodic actually solves the set interval thing. So what I want is to say hello every second, but I want to already have some sort of cancellation. I don't want to have this running forever. So let's say I want to tell most that I just want to do it 5 times, right? And if I run this, if I run this, as you can see, nothing happens, because it also doesn't have the problem of executing immediately. In this case, the syntax is not exactly the same. It's not run, but it's observe. So if I do observe, and I pass some side effect, then fine, it executes 1, 2, 3, 4, 5 times, and it goes away. So as you can see, it deals with multiple values asynchronously. It has many ways of canceling that are very natural to write because you're just thinking that you're dealing with an array, and it doesn't execute immediately. So it solves also most of the problems. Maybe this is why the name is most, I don't know. So if you do final thing, as I mentioned, if you have something that deals with a list, you can always deal with just one value. So if I do most of 1, I have just one value, I can just do observe console log. There you go. So this just gives me the value 1, but it's still like a promise that returns 1, right? So I can do asynchronous computations with these values. So I guess I touched some problems, I touched some solutions. There are others, of course. These are the ones that I like the most. I'll keep using this pun, I know. And I just wanted to show you this repo because actually a lot of the content that I developed here was based on, I was trying to think what was the best concurrency model to use in the language that I presented yesterday. So this is why I tried all these libraries, but this guy already did this before me. So it has something like a to-do MVC for asynchronous computations. So he created this general problem, and he solved this problem in all the libraries available, and then he sort of tried to discuss what are the pros and cons, things that one library solves or not. And it's a very good research. And based on this research that I actually tried Folktale or Most and so on. So I guess that's it, and now we can have some questions.